In this video, we are going to talk about some ionic compound properties. There are 5 that we're going to talk about, and the first one is we're going to talk about that ionic compounds dissolve in water. And if we look at this animated GIF over here, we see the ionic crystal here, and it's being plucked apart ion by ion by these freely moving water molecules. You may notice that the water molecules arrange themselves around the ions in different ways because water does indeed have a slight charge to it, and because water has a slight charge to it, it is attracted to the ions and can therefore pull the ions out. So that's how ionic compounds dissolve in water, right? So here we've got our ionic compound, and these are water molecules. So it turns out that some ionic compounds will dissolve better than others, but we'll talk more about that in our unit on solubility. That'll happen later on in the year. All right, the second property we're going to talk about is that ionic compounds are hard solids at STP. STP means standard temperature and pressure. So that's the S, the T, and the P. And this just is referring to normal conditions and at normal conditions, right? So ionic compounds are hard solids. They form what is called a crystal lattice structure. And we can see here that both on this diagram on your handout, but also on the screen, that depending on the charge of the ions and the size of the ions, those ions can arrange themselves in the most packed way possible. And these different crystal lattice structures will lead to crystals having different structures when you're holding like a crystal in your hand. They'll have different number of faces and the way those faces, the angles of those faces, but crystal structures are very much dependent on the crystal lattice structure of the ions in the ionic compound. All right, the third property of ionic compounds we are going to talk about melting point. Ionic compounds are considered to have a high melting point, which is, of course, the temperature at which a solid will turn into a liquid. They also have high boiling points, which is the temperature that the liquid turns into a gas. But generally, since ionic compounds are solids at room temperature, we talk about melting points. And they will have high melting points, which generally means if their temperature is 200 degrees Celsius or greater, that's considered to be a high melting point. We also say that ionic compounds have a low vapor pressure, which means that they do not evaporate easily. Meaning evaporate, of course, is going from a liquid to a gas, right? And so they're not going to evaporate easily because if it takes a lot of energy just to turn them into the liquid phase, it's going to take a lot of energy to turn them into the gas phase. That's not as commonly talked about because, again, ionic compounds are solid at room temperature. The explainer here, if you're looking at this, if we're looking at this negative ion here, notice that it is surrounded by positive ions all the way around in all three-dimensional directions. So what we have here are many attractive forces in all the directions, prevent those ions from loosening, and they are very rigidly stuck in place, and it's going to take a lot of energy to loosen those and make them start to flow. All right, let's take a look at the fourth property we're going to talk about, which is that ionic compounds are brittle, which means that they shatter easily. You can see it more readily here. We've got a blunt force, which forces this group of ions to shift, to physically shift. And what will happen is it causes this negative ion to be seated next to this negative ion. And that repulsive force causes the shattering to happen. You can see it here in this animated GIF as you push this layer in this direction, if you look at the yellow negative ions, when you move that negative ion close to another negative ion, that repulsion effect is going to push this layer right off. So we can say that the blunt force causes the ions of the same charge to sit next to each other. And then that repulsive force of those like charges causes the breakage and the crystal shatters. Okay, so that is the fourth property. The last property is electrical conductivity. Electrical conductivity happens for ionic compounds only in two situations. When the substance is liquid, meaning it is melted or molten, or when the substance is dissolved in water, otherwise known as being aqueous. But not when it's solid. When ionic substances are solids, those ions are fixed rigidly in place and they cannot move. If those charged particles cannot move, it is not conductive. It will not conduct electricity. When it is molten, meaning liquid, or when it's aqueous, which means it's dissolved, then those ions are now free to move. And when you have charged particles that can move, it can conduct electricity. So the explainer here is that ions are just charged particles that are now able to freely move. And when you have freely moving charged particles, this is known as electrical conductivity. So ionic compounds can conduct electricity when they are in the liquid phase, or when they are dissolved in water, but never when they are in the solid phase. Ionic compounds are brittle. They shatter when struck with a blunt force. Ionic compounds have a high melting point. They are arranged, their molecular structure is a crystal lattice structure, and they are soluble in water. All right, well, that's it for this video lecture. We will see you back in the classroom.